Recently, surfing through internet, I found an interesting case that puzzled me for some time, and today I would like to share this puzzle with you. So the request was rather simple. I'm looking for a formula that looks in a cell to find a number greater than 2000 and less than 3000 and return that value. Otherwise, return none. Person used search function, but it wasn't correctly in 100 cases. So there is a need to arrange it for a high number of arrays or big number of ranges so that it will help us to find all correct numbers. This is the pre-story of a correct number puzzle. So just to summarize key points. First, the input text may contain number. Number in this text should fit a range from 2000 until 3000. If number is not found, or found number is not in the range we are looking here for, function should return none. And as usually, from my side, we are going to create a VBA solution and non-Visual Basic for application solution. So we start now. To test our solutions, I have created several test cases. It contains lines where we are having the number that fits our ranges, lines where we do not have any numbers at all, and lines where we are having numbers outside of our range. How you can apply this case in your everyday life? If you are working with extraction from different ERP systems that usually returns the text, you probably need to normalize the data before doing any calculations. So, how many times you have faced that SAP returns some messy data that you would like to be converted into the split of ranges, text, and numbers so that further on you may calculate it? That's exactly the case we're going to learn today. We're going to create a user-defined function that will help us to solve this case. As you can see, I have already pre-created the function, so we will need just to copy it to our Visual Basic for application environment and investigate how it's operating. You can also find this text in the comments below this video. What I'm going to do now is to select the function, go to Developer tab and Visual Basic, insert a module into this workbook, and insert the text of the function in the popped-up window. So how the function is working? It accepts only one parameter, that is the text we are going to analyze, and will return a variant. Because if we are going to complete the task, it will return the specific value in this text, otherwise it will return none as requested in the task. The next line shows us a check for an error. If we are going to face any error in our function while resolving any specific case, we are going to move to the next line. The next, we are going to declare several variables. First one is going to be input length. It's going to be 3 digits less than the length of original input text. That will allow us to cut our input text into the digits of 4 symbols, and we are going to use it in our loop. The next two variables are going to contain the top and the low values of our range. In our case, if you will go a few lines down, you may see that we are going to preset them equal to 3000 and 2000. The last variable that we are going to declare here is a calc data, so this is going to be a temporary value that we are going to use for different calculations in the formula. As soon as we have declared our functions, we are going to make them equal to some value. So first one, as it's been mentioned, we are going to have input length by 3 digits less than length of original input text. And top and low values we have already covered. So now it's time for us to open the loop. We're going to start for loop. That will start with 1 and will be complete when we're going to reach input length. In the next line, we're going to select a medium value from input text starting with a position I that's going to iterate while the loop will evolve, and we are going to take only 4 digits from input text. In the next line, we are going to convert the values that we are going to extract from input text into the long number. If we are going to face the error, and that's in particular why we are having the first line in this formula, we are going automatically move to the next line, and it is blank. So we are going to move on further. Now we need to check what's going to be the type of the variable that we are having in calc data. If it's going to be error, function will just ignore it. But if it's going to be a long value, that means that we have found a number in this input text. We're going to check it if the calculated data fits the range that we are having. If it is so, then we are going to make sure that the function will be equal to the calc data and will stop function to return the value. If the function will not return us anything positive, we are going to return none, as it's expected by this puzzle. So now let's check our formula. So the formula names correct number. So now I'm going to select correct number. As you can see, it's automatically added to autofilling. And I'm going to insert the only variables that's requested from the test case. In the first line, we are having the number that fits our conditions, and this number is 2030. Now let's complete all the ranges below. So now you can see that formula is checking all the lines. What is important here, we can autocomplete as much as the number of test cases you are having. And that's how the Visual Basic for Application solution will work for us here. Non-VBA solution is going to be a little bit more complex because you are to repeat the same steps and not just copy-paste the function into your file. However, this approach will help us to learn what is iterative calculations and how it is working. What is iterative calculations? This is a type of calculations when in cell we are having the formula that is linked to the same cell and uses the same data to convert it and to use it in a future calculation. To make it available, you may need to go to the options. To do that, you will need to click File and Options. Now you need to go to Formulas and enable iterative calculations. As soon as we are talking about the range of 1000, we need to select for the first value 1001. This is going to be our presetting. Now let's turn to the function. To create a function, I have developed a small solution tree that will help us to follow the logic and to create it easily. I have also utilized few buffer columns. So I would like to explain you their purposes. In a position buffer column, we are going to store the position of the value that function results will be available in the test case. So if I'm going to receive 2030 in a functional column, I would like to receive 6 as a position of this text in the test case. This is a original buffer, and this is going to be a trigger to start the calculations. It will be just equal to original test case. I have also added 2 items that will represent the minimum and the maximum values of the range we are going to work in. So now we are ready to start creating the function. Let's start with following the logic that is available to the right. So we're going to start function with the first if. We're having the first statement, so if it is same value. As you remember, we are having original buffer column, so this is where we are going to check that the test case hasn't been changed. It is important for us to have it so that if we're going to start using different cases, or we are going to change the test case, it will restart the calculation from the beginning. So as we are talking about if function, we can see that if we're having no, it should be equal to minimum value. So we're going to pre-select that value if false will be equal to minimum value. What is important? We're going to make it absolute link. And now, just to check, we're going to place 1 to see if it's equal. So you can see that the first iteration returns us 2000 that fits the minimum value of the function. So now I would like to check the basic logic, and I will make original column equal to the test case. So you can see we are having 1 returned back. Ready to move to the next step. So we are again creating an if statement and we're going to check what we're having here. Have not found. That means that in a buffer position column we are going to have error. So we are going to return iserr function and we'll make it to position. So if it is not found, we are going to return 1. If it is not found, we are going to make it equal to self. So this is the first time we are going to make the function refer to the same cell we are operating in. Enter. It is saying as 0 because the original function cell that we are currently working on was containing nothing, so it returns as 0. It's returned as because we are not having anything in position column, so it's not an error. Now let's check for that. Let's make search, find text within the text of the test case, and there's going to be more than enough. It returns as 7. That means that we are having 0 as a part of the number. But this is not where we are going to work on. Therefore, as you remember, we are going to restart calculating with deleting the original value and then returning it back. So we are still in error mode. However, we are in 1. Ready to move to the next step. Self is text. Let's check this one. To do that, we are going to create additional if statements, and the check we're going to test if the cell is text. This is the second time we're referring to the same cell. So we're going to select if statement equal to self. If text, it means that it is not found. And if no, we're going to jump directly to the next if statement. We are going to check if we're going to increase the value by 1. It is still going to be not more than maximum value. And we also need to make it absolute. If it is going to be more than maximum value, then we need to return the text none, as it's been requested in the conditions. However, if it's not more than maximum value, we're going to iterate it by 1. So we're going to refer again to the same value and increase it by 1. So now if I'm going to click enter, we're going to make sure that the function column contains the right answer. We are not having it still yet, but you remember that we need to restart the calculation. So for that purpose, we are going to make original column equal to the test case. And now we have it in place. So let's complete with this function the whole column, the same for position and the same for original. So now you may see that we have received the same values, except for the first one, but again, this is more about the case for us to restart the calculation. It takes some time. So this is really important for us not to forget. Why this approach is more efficient? Because here we are pretty flexible in selecting the original range. So for instance, we would like to select everything that states from 1500s until 2500s. So now I'm going to delete original column and I'm going to do the same equation. So now you can see that we have received new values that are fitting new range, but old ones are not in place. To make them available, we need to change the presettings and to recomplete the calculations again. Again, the first option was much easier to implement for you for every day. But if you're interested in how Excel is calculating values, what is iterative calculations and how you can use it more often, find in the description below link to the 40% discount on iterative calculation masterclass available today for you. If you have found this video useful for you, don't forget to like it and subscribe if you are looking forward to see more complex cases or some basic techniques that we are already working for you. Thank you for watching and cheers!